This video covers note 17.3, which is RC3 Day 1 that we are doing on Monday, April 16th. So, for our student notes, some of these things have been filled in for us. The first part is domain and range of linear functions. So when we look at linear functions, there's two types of functions. You can have a continuous function or a discrete function. A continuous function is shown with a line as written down here. A continuous is a line. Even if it has two endpoints, it is still continuous because of the line that is shown. The line represents all of these tiny points all along the line. So every little X in here is listed on the line, and therefore this is a continuous function. Domain, if you remember Dr. XY, domain goes with X and range goes with Y's. So we started our dot. Our domain is shown through the x-axis at -4, and we continue to follow this line all the way through for domain. So it's kind of hard to see because my graph is bubbly, or like pixely, but my x's here are at -4, and as I follow the line, I'm using the x-axis, so I'm looking at the horizontal numbers. My x is at -4, then -3, -2, -1, 0. Remember, we're looking at the x's. 1, 2, 3, 4, 5, and so on because there's an arrow. So this tells me that my domain is everything greater than or equal to -4 because my x started at -4 and ends or will continue going bigger in a larger direction. My y's go from bottom to top or top to bottom. In this case, we're starting low. My range is starting at -3. And as I continue on that line, my y's are -2, -1, 0, 1, 2, 3. So my y's are also getting bigger. Now it's important to remember, one dot means one inequality. What also means one endpoint? But one endpoint means one inequality, but you have to figure out the direction that it goes in. We will see one later that has two endpoints, and I will remind you what to do with that. But here we have one endpoint, so we have to figure out, are my x's getting bigger or smaller? And as I go up, are my y's getting bigger or smaller? Now for a discrete function, the discrete function only includes the dots that are shown and nothing in between. So discrete means dots or points. These points have been listed for us, and your domain is all of your x values. So you can either look on the graph or look at all of the x's listed, and then your range is all of your y's as you go up, or you can list them from your points. These domain and ranges are not inclusive. They do not go everything from -1 to 5. It is those specific stepping blocks. So my domain and range have the squigglies on them. All right, now we're going to look at domain and range in a couple of different forms. So the first is a table. We're looking at number of pizzas purchased and the total cost of each pizza. So my pizzas, you can purchase 1 or 2 or 3 or 4. Traditionally, we do not order half of a pizza. There are places where you can go to order slices, but that's not what we're talking about. We're talking about if you call up Domino's, you cannot ask them for 1.5 small pizzas. You can get pizzas at different sizes, but you cannot get them in different increments. You buy whole pizzas. So because you cannot break up the pizzas, it is discrete. So remember, discrete is distinct separate dots or points. You can get 1 pizza or 2 pizzas or 3 pizzas or 4 pizzas. They're all separate. Continuous is when you can go in between. So my domain is just all of my x values listed, and my range is just my y values listed. So all of these are separate, distinct points. So we write them out, and remember we put the little squigglies around it, so that could have been a clue to you as to what type of function it is. With an equation, we have h of x equals negative 0.75x plus 5. Now with these, we don't know what type of function or what this is talking about. So if we have an x, I could plug in 1 for x, 2 for x, 2.5, 2.6, 2.78932. I could plug in whatever value for x that I want. So this one is going to be continuous. Now the picture is drawn here. This is what it looks like if you plug it into your calculator. I would be careful because you can plug problem 1 into your calculator, but if you don't think about the problem, then you don't know if it's really discrete or continuous. But if you're given an equation, then you can look on a calculator. If they do not tell you what it's about, then it's going to be continuous. If they tell you what it's about, like how we knew this was about pizzas, then we have to be careful. My domain and range for both of these functions is going to be all real numbers. So you can do the double R or you can write all real numbers, but domain and range for any lined equation is all reals. We also have 2 real-world scenarios. The first is about Dylan. Dylan lives 2 miles from AMCHS. He walks to school every morning at a rate of 1 mile for every minute. The distance, 1 mile for every 12 minutes. The distance he has remaining, y, is a function of how long he has been walking, x. So the first thing we need to ask ourselves is, what does x represent? Well, they just told us x is how long he's been walking, and y is the distance remaining. Now, x, how long he's been walking, has to deal with the minutes. He can do 1 mile every 12 minutes. So we need to ask ourselves, is it possible to break this up? Does he walk only in mile increments, or can he walk parts of a mile and parts of the minutes? Well, if you think about it, when I walk across a room, I don't jump from corner to corner. I take steps in between. Just like Dylan, he can't hop 1 mile, 2 mile, and be done. He walks 1 mile every 12 minutes, so we know he can't hop that far. So this one is going to be continuous because you can have in-between measurements for your time and for your distance. You don't jump miles and you don't jump minutes. So this will be continuous. Now my domain and range have already been started for me. My range is my y's, and my y's, as they told me, is the distance remaining. Now he has a maximum distance of 2 miles, and it takes him, once he gets to school, he's at 0 miles. So my range is going to be everything from 0 to 2, where 0 and 2 are included, because if he walks all the way to school, he has 0 miles left, and that's possible. And if he's at home, he still has the full 2 miles left, so that's possible. My domain is talking about the time, and we've kind of written it out over here for you. To go 2 miles, he has to go for 12 minutes for 2 miles, 12 minutes for 1 mile. So if he goes 2 miles, each mile is 12 minutes, so it's a total of 24 minutes on the domain. Now, if he walks nowhere, he can walk for 0 minutes, and that's possible. And if he walks the full thing, he can walk up to 24 minutes. And if he walks all the way to school, it will take him the full 24 minutes. So both of those would also be included. And the last situation we have about this is about Sarah. The function y equals 100 minus 17x represents the total cost for Sarah to rent a power washer. She is charged $17 each hour, and she can spend at most $100 on the power washer. And we have a little note down here. She is charged by each hour, no half hours. So if she rents it for 1 minute or 59 minutes or a full hour, she's still charged the same amount of money no matter how long she uses it. So what we did was we put 100 minus 17x into y1. Sorry, I'm trying to pull up my calculator. So 100 minus 17x. And we looked at the table. Now we have until she runs out of money, because y represents the amount of money. So if she has negative money, that means she now owes the company, and that's not okay. So 5 hours is going to be the lowest x. So you can rent it for 0 hours or up to 5 hours, and those domains are listed. And remember, because she cannot break up the hours, it is listed with the little brackets or braces. And then the range is these amounts that correspond with the 0 through 5s on the x's. All right, excuse me. Now we have a little reminder here for you. If it is an open bubble, your endpoint is going to be with no line under the inequality. But if your endpoint is filled in, there's going to be a line under your inequality. So keep that in mind as we fill in these lines. So here we're given this graph. We have a starting point at 6, negative 8, and we go across the line. So looking at my domain, my x's are going that way. As I follow the line, my x value, remember x's go across, starts over here, and my x's go this way. So my x's are at 6, 4, 2, 0, negative 2, negative 4, negative 6, negative 8. So my x's are getting less than the number that they started at. So my x's are getting less than 6. My y's go up and down, and remember we use like a little frame from our arrow to draw our domain and range. So my y's, in this case from the endpoint, are going up. My y's are at negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, and so on. So my y's are getting bigger than. So remember, anytime you have one starting endpoint, that's kind of an oxymoron, but one point, you have to determine which direction the arrows are going in. We're going to look at one over here where they're always less than because you have more than one. But over here, we start at that point and follow our line along. My x's go left or right, my y's go up or down, my line is directly in between them. You can also use your sticky notes. If you have those in your baggie and plan to use them, you can use your sticky notes to cover up what you're looking at. Remember, this is your x-axis for your domain, and up and down is your y-axis for your range. So this graph over here, domain, remember, is your x values. So x's, I go all the way to the left and then all the way to the right because this is my x-axis. So again, if you have your sticky notes, you can put them on either side or just draw your lines on the far left x and the far right x. When you are given more than one point, you will always use less than signs, and the only thing you have to determine is if the bubble is open or closed. This x goes all the way out to negative 6. And then my positive, or my biggest x, goes all the way out to positive 8. So with your domain, we go left to right, no matter what that looks like if you have 2 points or more than 2 points. So left x to right x. At 6, I have an open, negative 6, I have an open bubble, so I leave the inequality alone. At positive 8, I have a filled-in bubble, so I put the line under the inequality. Range is your y's. So on your y's, you go bottom to top. So on my y's, I'm down here at negative 4, and then my y's go all the way up to 8. Notice that I use the entire function, not just the endpoints, because the endpoints are not my lowest and highest points. So with my y's, I go all the way down to negative 4, way down here. And with my y's, I go all the way up to positive 8. Both of these values are filled in. There's no open bubble. And so I leave them as I see them. All right, now the second thing we're going to look at is different forms of linear equations. And so we're looking at all three forms. This left example I'm going to go through, but not super clearly, quickly. So the first thing I know when I read this equation is, or this information, is they're giving me a line with a slope of -1/2 that passes through the point -4, 5. So I'm given a point and a slope. A point and a slope. So because I am given a point and a slope, I would start this in point-slope form. So point-slope form is y minus y1 equals m times x minus x1. They plug in their m value, their y, and their x. And remember that your points change signs. So the point x, y is actually -x, -y, or that's kind of confusing. In the form, they tell you that you change the signs. So because I have a +4 here, it really means I started with a -4 and changed the sign. Because I have a -5 here, it means I really started with a +5 and changed the signs. From there, from point-slope form, I could solve for slope-intercept form. I would take the point-slope form that I've written, distribute -1/2, so -1/2 times x is -1/2 x, -1/2 times 4 is -2, bring everything else down. Slope-intercept form is where you try to solve for y and get y completely by itself, so I would add 5 to both sides. My slope would be exactly the same because slope-intercept does not change your slope, and -2 plus 5 is 3. Once I have slope-intercept, I can solve for standard. Standard form is where you have your x's and y's on both sides together, and you have 0 fractions. So remember, these are listed off to the side if you want to look at them, but that's how I know what I'm going for. So the first thing I would do is put x and y together. So I would add 1/2 x to this side, so I have my x and y together, and then the only thing left on the right side is equals 3. From here, I have to get rid of the fraction, so I would multiply every piece by 2 because that gets rid of my fraction. I just have a plain x. 2 times y is 2y, and 2 times 3 is 6. So let's look at this example. They tell me a line that has a y-intercept of -2, so that's the point 0, -2, also contains the point -3, -7. So the first thing we can do is use the calculator to figure out what to plug in, because I have 2 points. So I would take those 2 points and put them in stat edit, and it would tell me A is 2 and B is -3, and that's how I get slope-intercept form. So this is from stat calc 4. Now from here, I have my slope of +2, and I just pick any points from the beginning and plug in. So with point-slope form, remember you change your signs. So -7 turns into +7. My slope of 2 goes in front where m goes, x, and -3 changes to a +3. Now, all they asked us to do was put it in point-slope form, so that's all I have to do here. Excuse me. Now, to do standard form, I'm going to take slope-intercept and make it match. Remember over here, standard form has your x's and y's together. So I need to move my x to the other side using the opposite operation. Now, once I've moved my x, because I would add or subtract 2x from both sides, rewrite because they're not like terms, you can stop here. However, there are some problems on your assignment where the answers are listed like this, where this does not match what I got, but if you notice, all of the signs are opposites. Negative 2x is a positive, positive y is a negative, negative 3 is a positive. These are the same. So if you get an answer and it does not match any of the answers listed, then you need to see if there's a way you can just change a couple signs and make it match. All right, so we're on page 3, I believe. They ask us to write each of the following equations in slope-intercept form. Remember, slope-intercept is the nicest because you just have y, you don't have any parentheses. The calculator gives it to you in y equals. So if you're given a table with points, you put your table into stat edit and do stat calc 4, and what it shoots out is your answer. So this one has already been done for us. Excuse me. But you just take your list 1 and list 2, make your calculator match your paper, stat calc 4. If we're given a graph, M and B, remember, are your slope and your starting points. We start on the y-axis at -5. And my slope is found by going from point to point, so up 3, right 4, so my slope is 3/4. Remember that slope and x go together, so 3/4 x go together, and then a -5. Next, we have a verbal description. A 3-foot tree is planted in the fall. If the tree grows at a rate of 7 feet per year, write an equation to represent its height, f of t, after each year t. So we know that it starts at 3 feet when it's put in the ground. So that is my B, my y-intercept, my starting point. From here, all I have to do is figure out my slope. Well, they've told me my rate is 7 feet per year, and each year is represented with t. So 7 and t would go together, and this would be my answer. Make sure when you use letters like T that you are very careful to make it a T and not a plus plus. This bottom equation has already been done for us, so I'm just going to talk you through what they did. The first thing they did was distribute the 15 and the 6. So they distribute. Remember, when we distribute, we multiply. So 15 times 1/3 x is 5x. 15 times 3 is 45. 6 times x is 6x. 6 times 9 is 54. So all of this comes from this first step of distributing. The next thing we do is get our x's on the same side. It does not matter which side. So they've subtracted 5x. 6x minus 5x is 1x. And they bring everything else down exactly like they see it. Then they get their numbers on the same side, which is the different side from x. So we subtract 54. Whenever we do to one side, we have to do to the other. Bring your x down because you haven't done anything with it. And 45 minus 54 is a -9. And I have x by myself, so I get to stop there. On this back part, part 4, writing linear inequalities, we have just some kind of vocab words to help you remember what ways that you write the inequalities. So if you see the word less than, you use a less than sign. And if you see the word greater than, you use a greater than sign. And if you see is less than or equal to, no more than, or a maximum, you use the less than or equal to sign. And if you see is greater than or equal to, at least, or a minimum, you use the greater than sign. These two we've been asked to translate but not solve, so we're just taking these and putting them into inequalities. In example 1, they tell us a 24-foot tall cedar tree is growing at a rate of 2 feet per year beneath some power lines that are 58 feet above the ground. The power company will have to prune or remove the tree before it reaches the lines. How many years can the power company wait before they take action? So we have some power lines here, and we have a little tree. Sorry, not an art teacher. Now, using this picture, we have two pieces of information. The power lines sit at 28 feet, 58 feet. The tree is at 24 feet and counting. When I look at this picture and I reread that the company will have to prune or remove the tree before it reaches the line, that tells me the tree can only get about this high. Now, we don't know exactly what that number is, but the tree has to be less than or equal to the power lines, meaning the power lines have to be the bigger number. If you remember back in second or third grade when you first learn about inequalities, the open mouth of the inequality eats the bigger number. So if you can't figure out less than versus greater than signs, then you need to figure out which direction does the alligator go. And I apologize because this is just an open mouth. It cannot be equal to 58 because it says that they have to remove it before it gets to the line. So when I look at this picture, my power lines are taller than the tree, so my alligator eats the power lines because the power lines are bigger, or taller in this case. Example 2, Jill is playing in a basketball tournament and scored 24 points in her first game. If she averages over 58 points for both games, she will win a trophy. How many points can she score in the second game to get the trophy? So on this side, we have her average, and on this side, we have the minimum points. Now this sentence right here kind of tells us what needs to happen. Her average needs to be over or greater than 58 points. So her average needs to be greater than or equal to the minimum number of points to get a trophy. So 24 plus x divided by 2 is going to be greater than or equal to, nope, because it says over 58, not 58. So she needs to average over 58 points. So she can score more than 58 and win the trophy. So anything where her average is greater than 58 will get her that trophy. The last problem has been started for us but not finished. So we have 17, negative 3 times x plus 4 is greater than or equal to 3 times x plus 9. So the first thing that has been done for us already is distributing negative 3 times x, negative 3 times 4, 3 times x, 3 times 9. And then in step 2 in blue, we've combined the like terms all on the same side. So 17 minus 12 is 5. Bring everything else down exactly like you see it. Step 3 is to move all of my x's to the left side. Now again, it does not really matter which side you put them on, but your goal is to put x's on one side, numbers on the other. But because this step is already listed, I'm going to go ahead and do it like it shows. Ugh, I apologize. Now, once we get our answer and we read our answer, it is easier if your x's are on the left side. But it does not matter truly once you get your answer. But most of the EOC answers, the x's are going to be on the left side, which is probably why they're doing this. The fourth step is to move 5 to the other side. Because I am subtracting, I do not yet have to worry about changing a sign. And then I divide by negative 6 on both sides because negative 6 is directly multiplied to x. Because I have divided by a negative 6, I have to flip my sign. Because I divided by a negative 6, I have to flip my sign. And then I bring the x down and negative 11/3 is what you get in the calculator if you put 22 divided by -6. On the back page, we have some quick vocab. So linear inequalities, coordinate pairs, solution set, and then quadratics, which we haven't really talked about yet today, but we'll be talking about in the future. So you might want to review that before we get to quadratics so you know exactly what to do when we get there.